Still continuing in present value annuities, I want to cover equity in this video, but before we get to that, let me show you a two-part problem that sort of puts the present value and future value working together to solve one problem. Marie has determined that she will need $5,000 per month in retirement over a 30-year period. She has forecasted that her money will earn 7.2% annual rate compounded monthly. Marie will spend 25 years working toward this goal, investing monthly at annual rate of 7.2%. How much should Marie's monthly payments be during her working years in order to satisfy her retirement needs? Okay, so this problem is really a two-part problem. So let me show you what I've drawn down here. This horizontal line represents the timeline starting at from when this is where Marie starts working, and this is where Marie ends her 30 years of retirement, and then in the middle is where she switches from working to retirement. Okay, so the first part, you can't answer this question until you answer this first part. And so the first part is you need to know how much money Marie needs in the bank right here when she begins her retirement. So what that is, to get part one, that's actually present value. So she needs present value. So what we're going to do is we're going to find the present value that will allow her to withdraw $5,000 per month for 360 months. Okay, and then that way we'll know how much money she needs when she retires. So we'll do that first. So here's the present value formula, and we know that she's going to withdraw payments of $5,000 per month. We know that I is 0.072 divided by 12. So using the formula, we get 1 minus the quantity 1 plus 0.072 divided by 12. And we know she's going to want to withdraw these payments for 360 months. So N will be 360. And then, of course, we divide by I. That comes up to be $736,606.78. So that's how much she's got to have right here at retirement. Now, the question is, remember, here she's going to make a payment each month, payment here, payment here, payment here, and so forth, for 25 years or 300 months. So the second question, we need to find the monthly payment that will grow to the present value that I found in part one. So this is actually a future value problem. So I'm going to have to use the future value formula, not the present value formula, but the future value formula where I'm solving for payment. Because actually what we're doing is a sinking fund here. So the sinking fund formula, you take the future value, 736,606.78, that's what we need, and you multiply it by I, 0.072 over 12, over 1 plus I to the N minus 1. So notice here I have 1 plus I. Now remember, her working years are only 300 months, so N would be 300 here. So when you calculate that, you'll get $880.91 or 90 cents. So she needs about $881 a month to deposit into the account when she's working to make this happen. Now that sounds like a lot, but actually if she gets a job that matches whatever she puts in, she only needs to put in half of that, and then the company would match the other half. Now, here's an interesting question. After retirement, we expect Marie to withdraw $5,000 per month from her balance of $736,606.78. But let's see what maximum amount Marie could withdraw each month so that her balance never decreases. There's a very simple way to do this. All you have to do is find the interest earned on the first period. So just use I equal PRT. You start with a principal of $736,606.78. You multiply it by the rate, 0.072, and then times the time for the first period, which is 1/12 of a year, and you get $4,420. So that tells us that if she were to withdraw $4,420 each month during retirement, then her balance would never decrease. The reason being is because every time she withdraw $4,420, that would just be the interest that she earned the previous period. As you make payments on an item like a house, you build up equity. Now, equity is the difference in the fair market value of an item less how much you owe on the item. So let's take a look at the equity on a home. Okay, so here a man purchased a home 10 years ago valued at $80,000. He purchased it by paying 20% down and a 30-year mortgage at 6.6% compounded monthly. Today, the net market value of the house is $120,000. How much equity does the man have in the house today? Well, first of all, we can't calculate the equity on this home unless we know the monthly payment. So let's find the monthly payment that the man's paying. So I need the amount financed. Now, to get the amount financed, I can do it two ways. I can either figure out what is 20% of $80,000, which is $16,000, and take that away from $80,000 to get $64,000. Or I can just say, well, if you pay 20% down, then he only financed 80%. So if you finance 80% of $80,000, that would be 80,000 times 0.8, which is 64,000. So either way, he financed 84,000. Now, to find his monthly house payment, I use the formula for amortization. The payment would be the 64,000 times I over 1 minus 1 plus I to the negative n. Remember, it's 30 years, so n would be 360. So now when I calculate that, I get a monthly payment of $408.74. Now, to calculate equity, I need to know how much he's going to owe on the loan after he makes these 10 years worth of payments. Okay, well, remember 10 years of payments, that means he made 120 payments. 10 times 12 is 120. So that means he has remaining 240 payments. Now remember, to calculate the payoff, you find the present value on the number of remaining payments, not the number of payments you've made, but the number of remaining payments. So I need to find the present value for this payment, $408.74, on the remaining 240 payments. So using the present value formula, I get $408.74 times 1 minus 1 plus I to the negative n, where n is the 240 remaining payments, then divided by I. So that means at the end of 10 years, the man owes $54,391.91 on the house. Now, since equity is the difference in the fair market value minus the payoff amount, or what he owes on the house, we just take the fair market value of $120,000 less the payoff amount, $54,391.91, and that gives us $65,608.09. So that means this gentleman could sell the house and basically profit over $65,000. Or if he wanted to, he could borrow against this equity and do home improvements or put in a pool or something like that if he wanted to. So equity can be used in a couple of ways. One as a profit, but also you could use it to borrow against to remodel your house, or if you needed money for other things, you could actually borrow for that as well. Here's another problem. It's just another equity problem. So basically, you can read it. It's basically the same as the problem I just did. So let me just go ahead and tell you how to solve this one. He paid 10% down, so if you calculate 90% of the purchase amount, you get $135,000. And to calculate their monthly payment, you just use the amortization formula. So here's the annualization formula. I turns out to be 0.004, so you just multiply that by I over 1 minus 1 plus I to the negative 360 and get a payment of 708.30. And then he has a remaining 16 years of payments, which is actually 192, not 92 months, but it's actually 192 months. So that should be 192 months. And then to calculate the payoff, you just calculate the present value of that payment for 192 months, and then you get 94,796.87, and then subtract that from the fair market value, which in this problem is 190,000, and then the difference between the fair market value and the payoff of the loan would be, to the nearest dollar, would be $95,203. In this last problem, I'm going to calculate the annual rate. So it says, suppose you want to buy a $20,000 automobile and you want to pay it off in 60 monthly payments of $375 per month. What's the annual interest rate that will allow you to pay the debt off in exactly 60 payments? Well, since I'm paying off a debt, I know that I use the present value formula and the present value is $20,000. The payment is $375. And then I have 1 minus 1 plus I. Now here I'm going to let X be R, so I would be R over 12. And I'm going to pay it off in 60 months, so that's raised to the negative 60. And then all divided by I, which is R over 12 again. I'm using X for R. Now, divide both sides by 375, and I get 53.3333. Now, as I showed you before, all I want to do is graph these two functions. So if I graph this function, that will give me this horizontal line right here. And then if I graph this function here, that will give me this blue piece right here. And then I find where those two intersect. And notice they intersect at 0.04735. So it looks like the rate that I would need would be about 4.735%. Now remember, on the problem I did in the future value section, I solved for I and then I multiplied it by 12 to get R. But in this example, I went ahead and set the formula up where I would solve for R. That's what the X represents. And I didn't have to multiply it by 12 since I solved for R. Okay, well that pretty much completes all of the problems on this Math of Finance module. And so you can go ahead and, after you finish this, go ahead and move into the next module if you want to see future videos.